Hello everyone. Welcome back for like this week. I hope everything was okay, but first of all, I'm sorry for doing this late. I had some things going on at school and I had to stay like up to 5, something like that. But either way, we're here. That's what matter. Late, but here we are. Also, we're going to finish this today. Last question. Sorry for last week. It was crazy. Basically, this last question. We had to do a lot of things. Maybe I just like start to think too much. I don't. But either way, let's do the last one. Now, where is the area of the trapezoid? Okay. I'm sorry about that. Sorry about that. Either way. Um. Okay, what is the area of the trapezoid? Okay, this is gonna be a fairly easy question. So here, first of all, we know area multiplying whatever. We don't have a specific formula for this trapezoid because it is not like these sides. These sides are not equal. Like we can clearly say it. So we don't have a specific formula for that. But um, like we know how to calculate this. I mean, we can see this figure and we can say, okay, this right here is a triangle. I know my formula to calculate a triangle. This right here, okay, my bad. Right here is a rectangle, and I know my formula of the area of the rectangle. And this right here is another triangle. And if I add their areas, hey, this is going to be 83. So area 3, area 2, area 1. And if I add these areas, then I get the total area, which is what we're looking for. So basically, um, that's what we're gonna what we need to do. Now to start with, we know the formula for a rectangle triangle. Yeah, which is going to be like the area for a triangle will be area equal base times height over 2, or I have explained in the videos before, a equal 1/2 base times height. Either formula you use is the exact same thing. It's just the preferences. I will use this one. It doesn't like make any sense. First, we know that this is a right triangle because this is a right angle. Yeah. We can clearly see this is a horizontal line, this is a vertical line, so they are perpendicular to each other. And what I'm going to do is I'm going to say, okay, this is 1, 2, 3, and 4. So this is 4. Then this is 1, 2, 3, and 4, and 5. So this is 5. Okay. I have my base. I have my height already because we only need the length of the catet of the sides, not the hypotenuse. We know we need the length of the sides when it is a right triangle, and we can consider that as the base of the height. So I have here my side, which is 4 and 5, and I can say, okay, area 1 is to be equal 4 times 5 over 2. So this will be 4 times 5, 20. 20 over 2 is equal 10. Like 20 divided by 2 is 10. Okay, this is 10 units square because we don't have centimeters, we don't have millimeters, we don't have kilometers. Either way, um, that's what they're using here. This is not the answer. I just say like the units. Square units. Okay, I suppose we could put a square unit. Either way, you understand what I mean. Now, next, area 2. Easy peasy lemon squeezy. We know that the area of a rectangle is just side times side. It will be like a times b, side times side. We can say, okay, area is equal. We know, okay, I use, right. This is going to be one, two, three, four. And this is going to be five because we already counted. Um, it's the exact same as the triangle, but without without dividing by two, basically. So it will be 4 times 5. 4 times 5 is just 20. So it is equal 20. So this is 20 square units. And now it is 3. We come back to the formula of the triangle, like the area of the triangle, and we count this. We say, oh, okay, another color. Yes, this one. This is one, two, three, four, five, and then here 1 and 2. So those are sides, and we say base times height. So 5 times 2 over 2. This is going to be 10, like 5 times 2 is 10, and now 10 divided by 2 is 5. These are areas, and we want to know the total area. So we say, okay, area total, or AT, I will just say AT. It will be equal A1 plus A2 plus A3, which is equal 10 plus 20 plus 5. Now, 10 plus 20 is 30. 30 plus 5 is 35. And our answer is B. And that's it for this package. It has been very, very long. And I'm sorry about it. I cannot do anything else. That's it. If you have any doubt, go Discord. I'm sorry for those who are in Discord and cannot see my screen. I don't know how to fix it. I have tried many things to fix it, and I don't know what else to do. I tried to call someone, see someone. Like I cannot find the answer in YouTube or Google. I'll see what I can do to try to solve it. I'm sorry for the cut. I just wanted to come to the new package finally. On this topic for me is a lot easier than the others I mentioned before. I think. But let's just keep going. I'm going to start with the exercise, but I actually have this drawing here, so to go and explain a little bit more about the angles, like in an easier way. Um, well, I'm actually going to explain the angles first, so it's gonna be easier for you guys. So here, I'm going to start with the easiest one. This one is radius. This is a semicircle. You can see here. Every time you see a semicircle, it's going to be the same. So from here to here as well, and from here to here, and here, 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 and here. So all semicircles, they're all adjacent angles. Adjacent. And if you don't know, adjacent just mean next to each other. So that's basically a name. But you can also call them supplementary angles, as you might have heard before. Sorry, angles. And they are basically the means is that they add up to 180 degrees. So every time you see a semicircle, they add up to 180 degrees because they are adjacent angles or supplementary. Next, another one will be, let's see. Wait, let me see something. Okay. Okay, I'm going to say keep explaining the ones that are in like the one that I'm going to explain first all the ones that add up to 180. So you can like oops put them together. So 3 and A, I want to use them. As you can see, they are like next to each other. And what I used to remember them is that you can draw like a C, like a C. Actually, this is a C. I'm just drawing to the other side because I select 3 and 5, but it will be like this. A C. And you can see that the two that are inside, they are going to be consecutive consecutive angles. And just for you to know, this sign just means angles, so it doesn't mean anything else. And as I said, like I'm going to explain all this the add to 180 degrees together. Okay. First, so you can imagine that this add to 180 degrees. As I was mentioning, I use a C to remember them. So if I draw a C now to the right, you see that the one inside have 4 and 6, so they are consecutive angles. You can also see call them consecutive interior angles, but interior just means inside, and 4 and 6 are inside of the C. So basically, that's the reason of the interior um part, so consecutive interior angles. Um, I haven't seen this, but you can also say that two. You can also say that 2 and 8 are consecutive exterior angles because they are like in the sea, but they are right outside of the sea. I use it a lot more in Cuba when I did geometry there. But yeah, like I have never seen it here, but either way, just for you to know. And if you draw the sea here, oops, my bad. Let's see here. You see 3 and 5 are inside, so consecutive interior angles. 1 and 7 are outside, so consecutive exterior angles. Still consecutive. Now, the other, this is an easy one that I really like. I think it's cool for me. Will be this 6, 7. They are alternate angles. Alternate angles. Wait, no, never mind. Vertical angles. Ah, I'm going ahead. Sorry, vertical angles. I'm going ahead. My my brain is thinking. Sorry about that. Okay. So vertical angles. And for vertical angles, I just like to think about. Oops, my bad. Vertical angles. I just like to think about an X. So I have this, and I have this, and I say, okay, the one that are inside the X, like maybe like, you can even say, oh, forming like a sun wash. I think that's the translation of the word, like sun wash. Just in case I'm pronouncing wrong. Either way, I just think about an X, and they are like one like opposite to the other. So and those are the vertical angles. They are equal. They don't add to 180 except they are both 90 degrees, which obviously add to 180, but they are both equal. So if this one is 21, then this one is 21. If this one is 70, then this one 70. And these like 5 and 8 are also vertical angles. 4 and 1 vertical angles, and 3 and 2 are also vertical angles. That's it for the vertical angles. Now comes the turning angles. I was thinking ahead of my brain before. So vertical angles, yellow. I will say I will say that 8 and 1 are alternate angles. And how I remember the alternate angles is that I can draw a C, like Z. Okay, I'm going to make this bigger, like this. C. And they like I will say that the ones that are like this and the one inside, they are alternate interior because they are inside. And this one outside, they are alternate exterior because they are outside. And I could also draw a C to the other side. It's going to be like this. Like if I delete, my bad, I delete this one and I draw a C like this. It's also C, but it's the other side. So the ones in the inside are alternate inside 4 and 5, and the one in the outside are alternate interior 4 and 5, and the one in the outside 2 and 7 are alternate exterior. And that's it for the alternate. And also and they are equal, which means that if if 8 is 70, then 1 is 70. If 4 is 51, then 5 is 51, and so on with all the alternating angles. Now I'm just missing one more. It's consecutive, vertical, adjacent, alternate. Let me see the name because corresponding. Okay, now corresponding angles. For them, I always draw an F. So what I would do, another color. Nope, this. Okay, and draw an F here, an F here, and I will say that 4 and 8 are corresponding angles. Corresponding angles. They are equal to each other. So I also can draw an F to the other side. I'm going to use another color so you can see better and I don't have to delete this one and bigger. So if I draw an F like this, it'll be 3 and 7. They are corresponding angles, and also we can draw an upside down F like this. So 5 and 1 will be corresponding angles, and also we could draw an F like this. So 4 and 6 will be corresponding angles. And just for you to know, that's how I do it. So basically, if you don't understand, remember, go to Discord, ask me. There's a question channels there. You can send your question and answer them. So now, let's start with the first exercise. Let's go really quick. First, I go 4 and 9. So 4 and 9. Oops, let me make this smaller. 4, 9. Okay. What figure do I see? Okay, I draw this. Oh, this is Z. The Z. And Z, they are alternate angles. So I put here, okay, 4 and 9, they're alternate. Now, as you can see here, they want you to specify if they are interior or if they are exterior. Okay, I say my C, and what I see is that they are both in the inside part of the C. So they are interior. Interior angles. Now, 1 and 9. Okay, 1 and 9. Use another color. I say, okay, this is 1. Okay, this is 9. And if I draw a figure, oh, this is an F. So they must be corresponding angles. So I come here and I say, okay, corresponding angles. Corresponding. Now I go to 1 and 12. Let me do the F here. Okay, say okay, 1 and 12. I go here 1 and I go here 12. And I see that there is also a Z here when I draw the figure. So if there is a Z, they are alternate angles. But they want us to specify if they are interior or exterior. So I come here and say, okay, they're outside of the Z. So if they're outside of the Z, they are exterior because exterior means outside. So exterior angles. Now come here, another color. And say, okay, now 5 and 8. So 5 and 8. Oh, when I say this, I see an X. Okay, I see an X here. So an X is they are vertical angles. So then like 5 and 8 is just vertical. Vertical. Oh, 1 second here. Vertical angles. Okay, next, 6 and 11. I say that this is 6, this is 11, and this is like a weird figure, and for this I just recommend ignoring this. So we keep the line, we are just going to follow the line, and we can see that it is an F. Like I know it's upside down, but it's still an F, so they are corresponding angles. Corresponding angles. So that's my answer. And now, for the last one, oops, for the last one second. Sorry for any like loud that you can, anything like loudly that you can sound like outside here. Just ignore it. I can not do anything about it. So next is 3 and 9, and I have 3 here. Okay, there, like 9 was used for everything. Wow. Either way. Okay, this is 3, this is 9. What we can see here, I can draw a Z. They are inside of a Z. Like a Zeno, like Zeno is a Z. Like C, like C. Pronunciation. My bad. Sorry. My bad at this. Um, so a Z is with they are with consecutive angles. So these are consecutive. As I said before, they want us to say if they are interior or exterior. So, but in this case, um, they are inside of the sea. So since they are inside, they are interior. So interior angles, and that's basically it. Now I'm going to go faster. So now find the measure first. I say 41 and I say 1. I say that this is an F right here. This is an F. So they are corresponding angles. And as I explained it before, corresponding angles are corresponding angles are equal. So if corresponding angles are equal, this is 41, then 1 will be, like measure of angle 1 will be 41 degrees. Now, angle 2, I see that I will use the 41 again. We could do this 2 ways, and I'm just gonna do the one that is easy for me. So you see here and here, I see that this is an X. So they are vertical angles. And vertical angles are also equal. So the measure of angle 2 will be also 41 degrees. Now, next. Okay, this is 121 and 1. And I just see here, this is Z. So they are alternate angle because this is Z. They are specifically alternate exterior, but we don't care about that right now. So we just say alternate angles. And as I explained before, alternate angles are equal. So the measure of angle 1 will be also 124 degrees. Now, let me see one thing. Okay, great. Now, I see that right here, this is an X. So they are vertical angles. As I put it here, vertical angles. Can I put it in the middle? Because it applies to both. And I put both in the same color. So vertical angles and vertical angles are equal. So a measure of angle 2 will be also 124 degrees. Mhm. Um, I'm into the last one. Possibly gonna do this, only this one, and then tomorrow do this one. Either way, this is a refresher. Now I'm going to say okay, this is another color. Okay, this is 122, this one. As you can say here, I can do this is Z. So they're alternate angles, and alternate angles are equal. So, so the measure of angle 1 will be also 102 degrees. Now, this and this, I can see that there is also a Z here. So they are also alternate angles. The only difference on these were interior. These right here were interior, and now these right here are exterior alternate angles. But that doesn't matter. Alternate angles are always equal. So measure of angle 2 will also be 102 degrees. Now I see that there is a semicircle here. A semicircle means adjacent angles. Okay, I'm gonna do another color. Hmm, change style. Oops, change style. Yeah, and this is adjacent angles. And adjacent angles add up to 180 degrees. Now, I will say that the measure angle 2 plus the measure of angle 3 and angle 3 equal 180 degrees. Now I know the measure of angle 2. The measure of angle 2 is 102 degrees. So I will say 102 degrees plus measure of angle 3 equal 180 degrees. Now I want to leave the measure of angle 3 on one side. Doing algebra, you might remember from last year. So I subtract 102 degrees from both sides and I get measure of angle 3 is equal. 180 minus 102 is 78. So the measure of angle 3 will be 78 degrees. That's for answers. Um, yeah, that's all for today. I'm sorry, it's a kind of late. Uh, Yeah, no, wait. Let me finish the page. I don't want to leave this one. Also, I'm gonna go really fast. Um, yeah. First angle one. So I have this. Okay, first have 68. I have one. When I draw the figure, I see that there is an F here. See an F here. So F goes with corresponding angles. So corresponding angles were always equal as I put it. Okay, I put it here and I actually put it with the same color. So corresponding angles are always equal and they form an F. So I have an F here, and since they are equal, I will say that the measure of angle 1 is also 58 degrees. Now for angle 2, I see this, and I also see angle 1. And if I draw a figure, I will say that there is an Z, there is a Z. There's a C here. And with a Z, that just means alternate angles. Alternate angles. Okay, alternate. Okay, wait. Alternate. And that was this right here were corresponding. Okay, sorry about that. So, and what I mean about alternate angles is that they are equal. Alternate angles are equal to each other. So the measure of angle 2 will also be 68 degrees. Now I'm just missing one more, which it will be angle 2 and angle 3. As you can see, the figure right here will be a Z, C, like coconut. C like coconut. Z. So they are consecutive angles. And consecutive angles add up to 180 degrees. So consecutive angles, and they are up to 180 degrees. So I will do the same. I will say that measure of angle 2 plus measure of angle 3 equal 180 degrees. Now I know the measure of angle 2, so I will say 68 degrees plus measure of angle 3 equal 180 degrees. Now I want to leave the measure of angle 3 alone, so I will say, okay, I will subtract 68 from both sides, so this can get like eliminated, like 68 minus 68 is 0. 180 minus 68 will be 112 degrees. So the measure of angle 3 is 112 degrees. And that's the answer. That's basically how we're gonna do this. It's a lot easier, I think, than the one we did before, like the other package. Yeah, that's all for today. Hope it was helpful, and see you guys next week.